demand for AI is growing. Demand for AI will grow indefinitely. But of course, that's not sustainable. Again, it's not sustainable in terms of financially. And so at some point, there will be that correction.
Hello, and welcome to Environment Variables, brought to you by the Green Software Foundation. In each episode, we discuss the latest news and events surrounding green software. On our show, you can expect candid conversations with top experts in their field who have a passion for how to reduce the greenhouse gas emissions of software. I'm your host, Chris Adams.
So hello and welcome to Environment Variables, where we bring you the latest news and updates from the world of sustainable software. Now, today you're not hearing the dulcet tones of your usual host, Chris Adams. I am a guest host on this, a frequent guest host, Anne Currie. And my guest today is somebody I've known for quite a few years, and I'm really looking forward to chatting to, Holly. So do you want to introduce yourself, Holly?
Sure. So I'm Holly Cummins. I work for Red Hat. My day job is that I'm a senior principal engineer, and I'm helping to develop Quarkus, which is Java middleware. And I'm looking at the ecosystem of Quarkus, which sounds really sustainability oriented, but actually the day job aspect is I'm more looking at the contributors and the extensions and that kind of thing. But one of the other things that I do end up looking a lot at is the ecosystem aspect of Quarkus in terms of sustainability, because Quarkus is an extremely efficient Java runtime. And so when I joined the team, one of the things one of the things I asked was, we know this is really efficient. Does that translate into an environmental benefit? Is it actually benefiting the ecosystem? Can we quantify it? And so we did that work, and we were able to sort of validate our intuition that it did have a much lower carbon footprint, which was nice. But some things of what we did actually surprised us as well, which was also good, because it's always good to be challenged in your assumptions. And so now part of what I'm doing as well is sort of broadening that focus from, instead of measuring what we've done in the past, thinking about, well, what does a sustainable middleware architecture look like? What kind of things do we need to be providing?
Thank you very much indeed. That's a really good overview of what I really primarily want to be talking about today. We will be talking about a couple of articles, as usual, on AI. But really, I want to be focused on what you're doing in your day job, because I think it's really interesting and incredibly relevant. So, as I said, my name is Anne Currie. I am the CEO of a learning and development company called Strategically Green. We do workshops and training around building green software and changing your systems to align with renewables. But I'm also one of the authors of O'Reilly's new book, Building Green Software. And Holly was probably the biggest single reviewer contributor to that book. And it was in her best interest to do so, because I make tons and tons and tons of reference to a concept that you came up with. I'm very interested in the backstory to this concept, but perhaps you can tell me a little bit more about it, because this is something I've not said to you before, but this comes up in review feedback for me for the book more than any other concept.
Really?
Lightswitch Ops. People saying, "Oh, we've started to do Lightswitch Ops." If anybody says I've started to do anything, it's always Lightswitch Ops. So tell us, what is Lightswitch?
So Lightswitch Ops, it's about architecting your systems so that they can tolerate being turned off and on. Which sounds, it sounds sort of obvious, but historically that's not how our systems have worked. And so the first step is architect your system so that they can tolerate being turned off and on. And then the next part is, once you have that, actually turn them off and on. And it came about because I'm working on product development now. And I started my career as a performance engineer. But in between those two, I was a client-facing consultant, which was incredibly interesting. And it was, I mean, there were so many things that were interesting, but one of the things that I sort of kept seeing was, you sort of work with clients, and some of them you're like, oh wow, you're really at the top of your game. And some you think, why are you doing this way when this is clearly, counterproductive or that kind of thing. And one of the things that I was really shocked by was how much waste there was just everywhere. And I would see things like, organizations where they would be running a batch job, and the batch job would only run at the weekends, but the systems that supported it would be up 24/7. Or sometimes we see the opposite as well, where it's a test system for manual testing and people are only in the office, 9 to 5, only in one geo, and the systems are up 24 hours. And the reason for this, again, it sort of, comes back to that initial thing. It's partly that we just don't think about it. And, that we're all a little bit lazy. But it's also that many of us have had quite negative experiences of, if you turn your computer off, it will never be the same when it comes back up. I mean, I still have this with my laptop, actually. I'm really reluctant to turn it off. But now with laptops, we do have the model where you can close the lid and it will go to sleep, and you know that it's using very little energy, but then when you bring it back up in the morning, it's the same as it was without having to have the energy penalty of keeping it on overnight. And I think when you sort of look at the model of how we treat our lights in our house, nobody has ever sort of left a room and said, I could turn the light off. But if I turn the light off, will the light ever come back on in the same form again, right? Like, we just don't do that. We have a great deal of confidence that it's reliable to turn a light off and on, and that it's low friction to do it. And so we need to get to that point with our computer systems. And you can sort of roll with the analogy a bit more as well, which is, in our houses, it tends to be quite a manual thing of turning the lights off and on. I turn the light on when I need it. In institutional buildings, it's usually not a manual process to turn the lights off and on. Instead, what we end up with some kind of automation. So like, often there's a motion sensor. So, I used to have it that if I would stay in our office late at night, at some point, if you sat too still because you were coding and deep in thought, the lights around you would go off, and then you'd have to like wave your arms to make the lights go back on. And it's that is the sort of idea of like, we can detect the traffic, we can detect the activity and not waste the energy. And again, we can do exactly this with our computer systems. So we can have it so that it's really easy to turn them off and on. And then we can go one step further and we can automate it. And we can say, let's script to turn things off at 5 p.m. because we're only in one geo. And if we turn them off at 5 p.m., then we're enforcing quite a strict work-life balance. So maybe that's not the best example.
Nice work-life balance.
Sustainable pace. Yeah. Or we can do sort of, more sophisticated things as well, where we can say, okay, well, let's just look at the traffic. And if there's no traffic to this, let's turn it off.
Yeah. It is an interestingly simple concept. Of course, it's when people come up with something which is kind of like, it was like in some ways similar analogies, a light bulb moment of, it's why don't people turn things off? Because so Holly, everybody, is an unbelievably good public speaker, one of the best public speakers out there at the moment. And we first met because you came and gave talks at in some tracks I was hosting on a variety, some on high performance and on high performance code, code efficiency, some on being green. One of the stories you told was about your light switch moment, the realization that actually this was a thing that needed to happen. And I thought it was fascinating. It was about how, I know everybody, I've been in the tech industry for a long time, so I've worked with Java a lot over the years and many years ago. And one of the issues with Java in the old days was always it was very hard to turn things off and turn them back on again. And that was fine in the old world. But you talked about how that was no longer fine, and that was an issue with the cloud, because the cloud, using the cloud well, turning things on and off and doing things like auto scaling is utterly key to the idea of the cloud. And therefore it had to become part of Quarkus, part of the future of Java. Am I right in that understanding?
Yeah, absolutely. And the cloud sort of plays into both parts of the story, actually. So definitely the things that we need to be cloud native, like being able to support turning off and on again, are very well aligned to what you need to support Lightswitch Ops. And so that, there with those two, we're pulling in the same direction. The needs of the cloud and the needs of sustainability are both driving us to make systems that I just saw yesterday. Sorry, this is a minor digression, but I was looking something up, and we used to talk a lot about the 12-factor app. And, at the time we started talking about 12-factor apps, those characteristics were not at all universal. And then someone came up with the term the 1-factor app, which was the application that could just tolerate being turned off and on. And sometimes even that was like too much of a stretch. And so there's sort of the state aspect to it, but then there's also the performance aspect of it and the timeliness aspect of it. And that's really what Quarkus has been looking at, that if you want to have any kind of auto scaling or any kind of serverless architecture or anything like that, the way Java has historically worked, which is that it eats a lot of memory and it takes a long time to start up, just isn't going to work. And the sort of the thing that's interesting about that is quite often when we talk about optimizing things or becoming more efficient or becoming greener, it's all about the trade-offs of like, I could have the thing I really want, or I could save the world. I guess I should save the world. But sometimes what we can do is we can just find things that we were paying for that we didn't even want anymore. And that's, I think, what Quarkus was able to do, because a lot of the reason that Java has a big memory footprint and a lot of the reason that Java is slow to start up is it was designed for a different kind of ops. The cloud didn't exist. CI/CD didn't exist. DevOps didn't exist. And so the way you built your application was you knew you would get a release maybe once a year. And deployment was like a really, really big deal. And, you'd all go out and you'd have a party after you successfully deployed because it was so challenging. And so you wanted to make sure that everything you did was to avoid having to do a deployment and to avoid having to talk to the ops team because they were scary. But of course, even though we had this model where releases happen very rarely, the big releases happen very rarely, of course, the world still moves on. People still had defects. So what you ended up with was something that was really much more optimized towards patching. So can we take the system and without actually turning it off and on, because that's almost impossible, can we patch it? So everything was about trying to change the engine of the plane while the plane was flying, which is really clever engineering. If you can support that well done you. It's so dynamic. And so everything was optimized so that, you could change your dependencies and things would keep working. And, you could even change some fairly important characteristics of your dependencies and everything would sort of adjust and it would ripple back through the system. But because that dynamism was baked into every aspect of the architecture, it meant that everything just had a little bit of drag and everything had a little bit of slowdown that came from that indirection. And then now you look at it in the cloud and you think, well, wait a minute, I don't need that. I don't need that indirection. I don't need to be able to patch because I have a CI/CD pipeline. And if I'm going into my production systems and SSHing in to change my binaries, something has gone horribly, horribly wrong with my process. And, I have all sorts of problems. So really what Quarkus was able to do was get rid of a whole bunch of reflection, get rid of a whole bunch of indirection, do more upfront at build time. And then that gives you much leaner behavior at runtime, which is what you want in a cloud environment.
And what I love about this, love about the story of Quarkus is it's aligned with something non-functional requirements. It's an unbelievably boring name for something which is a real pain point for companies, but is also in many ways the most important thing and the most difficult thing that we do. It's like being secure, being cost effective, being resilient. A lot of people say to me, oh, well, actually, all you're doing with green is adding another non-functional requirement. We know those are terrible. But I say, no, we need to not make it another non-functional requirement. It's just another motivator for doing the first three well. Auto scaling is about resilience. It's about cost saving, and it's about being green. And it's about and being able to pave rather than patch, I think it's more secure. Actually patching is much less secure than repaving, taking everything down and bringing it back up. All the modern thinking about being more secure, being faster, being cheaper, being more resilient is aligned or needs to be aligned with being green. And it can be, and it should be, and it shouldn't just be about doing less.
Absolutely. And especially for the security aspect, when you look at something like tree shaking, that gives you more performance by getting rid of the code that you weren't using. Of course, it makes you more secure as well, because you get rid of all these code paths and all of these entry points and vulnerabilities that had no benefit to you, but were still a vulnerability.
Yeah, I mean, one of the things that you've talked about that Lightswitch Ops being related to is, well, actually not Lightswitch Ops, but the thing that you developed before Lightswitch Ops, the concept of zombie servers.
Yes.
Tell us a little bit about that, because that not only is cost saving, it's a really big security improvement. So tell us about zombie, the precursor to Lightswitch Ops.
Yeah, zombie servers are, again, one of those things that I noticed it when I was working with clients, but I also noticed it a lot in our own development practices, that what we would do was we would have a project and we would fire up a server in great excitement, and we'd register something on the cloud or whatever. And then we'd get distracted, and then we'd, sometimes we would develop it but fail to go to production. Sometimes we'd get distracted and not even develop it. And I looked, and I think some of these costs became more visible and more obvious when we moved to the cloud, because it used to be that when you would provision a server, once it was provisioned, you'd gone through all of the pain of provisioning it, and it would just sit there and you would keep it in case you needed it. But with the cloud, all of a sudden, keeping it until you needed it had a really measurable cost. And I looked and I realized, I was spending, well, I wasn't personally spending, I was costing my company thousands of pounds a month on these cloud servers that I'd provisioned and forgotten about. And then I looked at how Kubernetes, the Kubernetes servers were being used, and some of the profiles of the Kubernetes servers. And I realized that, again, each company would have many, many clusters. And I was thinking, are they really using all of those clusters all of the time? And so I started to look into it. And then I realized that there had been a lot of research done on it, and it was shocking. So again, I have to say, I didn't coin the term zombie servers. I talk about it a lot, but there was a company called the Antithesis Institute, and what they did, although actually, see, now I'm struggling with the name a bit, because I always thought they were called the Antithesis Institute, and I think it's actually a one-letter variant of that, which is much less obvious as a word, but much more distinctive. But every time I talked about them, I mistyped it, and now I can't remember which one is the correct one. But in any case, it's something like the Antithesis Institute, and they did these surveys, and they found that it was something like a third of the servers that they looked at were doing no work at all. Or rather, no useful work. So they're still consuming energy, but there's no work being done. And when they say no useful work as well, that sounds like a kind of low bar, because when I think about my day job, quite a lot of it is doing work that isn't useful. But they had, it wasn't like these servers were serving cat pictures or that kind of thing. These servers were doing nothing at all. There was no traffic in, there was no traffic out. So you can really, that's just ripe for automation to say, well, wait a minute. If nothing's going in and nothing's coming out, we can shut this thing down. And then there was about a further third that had a utilization that was less than 5%. So again, this thing, it's talking to the outside world every now and then, but barely. So again, it's just ripe for a sort of a consolidation. But the interesting thing about zombies is as soon as you talk about it, usually, someone in the audience, they'll turn a little bit green and they'll go, oh, I've just remembered that server that I provisioned. And sometimes, I'm the one giving the talk and I'm like, oh, while preparing this talk, I just realized I forgot a server because it's so easy to do. And the way we're measured as well, and the way we measure our own productivity is we give a lot more value to creating than to cleaning up.
Yeah. And in some ways that makes sense because, creating is about growth and cleaning up is about, it's about degrowth. It's about kind of like, it's like you want to tell the story of growth. But I've heard a couple of really interesting tales on zombie servers since you started. Well, since you started talking about it, you may not have invented it, but you popularized it. One was from VMware, and it was supposed to be a cost-saving thing. And it's a story I tell all the time about when they were moving data centers in Singapore, setting up a new data center in Singapore. They decided to do a review of all their machines to see what had to go across. And they realized that 66% of their machines did not need to be reproduced in the new data center. They had and that was VMware. People are really, really good at running data centers. So imagine that's like. But moving data centers is a time when it often gets spotted. But I also a differently disturbing story from a company that wished to remain nameless, although I don't think they need to because I think it's just an absolutely bog standard thing. They were doing a kind of thriftathon style thing of reviewing their data center to see if there was stuff that they could save money on. And they found a machine that was running at 100% CPU. And they thought, oh my God, it's been hacked. It's been hacked. Somebody's mining Bitcoin on this. Or maybe it's attacking us. Who knows? And so they did some searching around internally and they found out that it was somebody who turned it on a load test and then turned it off 3 years previously. And I would say that obviously that came up from the cost, but it also came up from the fact that machine could have been hacked. It could have been mining Bitcoin. It could have been attacking them. It could have been doing anything. They hadn't noticed because it was a machine that no one was looking at. And I thought it was an excellent example. I thought those two excellent examples of the cost and the massive security hole that comes from machines that nobody is looking at anymore.
Wow.
So, non-functional requirements, they're really important. And doing better on them is also green. And also they're very non-functional requirements are really closely tied together.
Yeah. I mean, I love both of those stories. And I've heard the VMware one before, but I hadn't heard the one about the 100%, the load test. That is fantastic. One of the reasons I like talking about zombies, and I think one of the reasons people like hearing about it, I mean, it's partly the saving the world, but also I think when we look at greenness and sustainability, some of it is not a very cheerful topic. But the zombie servers, almost always, when you discover the cases of them, they are hilarious. I mean, they're awful, but they're hilarious. And, it's just this sort of stuff of how did this happen? How did we allow this to happen? Sometimes it's so easy to do better. And the examples of doing bad are just something that we can all relate to. But on the same time, you sort of think, oh, that shouldn't have happened. How did that happen?
But there's another thing I really like about zombie servers, and I think you've pointed out this yourself, and I plagiarized from your ideas like crazy in building green software, which is one of the reasons why I got you to be a reviewer, so you could complain about it if you wanted to early on.
It also means I would agree with you a lot. Yes, this is very, very sensible, yes.
And one of the things that constantly comes up when I'm talking to people about this and when we're writing the book and when we're going out talking at conferences is people need a way in. And it's often that, that people think the way into building green software is to rewrite everything in C. And then they go, well, I can't do that. So that's the end. That's the only way in. And I'm not going to be able to do it. So I can't do anything at all. Operations and zombie servers is a really good way in because you can just do it. You can instead of having a hackathon, you can just do a thriftathon, get everybody to have a look at what's running that doesn't need to be running. Instantly halve your, it's not uncommon for people to find ways to halve their carbon emissions and halve their hosting costs simultaneously in quite a short period of time, and it'd be the first thing they do. So I quite like it because it's the first thing they do. What do you think about that? Is it the low hanging fruit?
Yeah, absolutely. I think it's the low hanging fruit. It's easy. It's kind of entertaining because when you find the problems, you can laugh at yourself. And there's no downside and several upsides, so it's this double win of I got rid of something I wasn't even using. I have more space in my closet and I don't have to pay for it.
Yeah. I just read a book that I really, really should have read years and years ago. And I don't know why I didn't, because people had been telling me to read it for years, which was The Goal, which is, it's not about tech, but it is about tech. It's kind of the book that was the precursor to the Phoenix projects, which I think a lot of people have read. And it's all about TPS, the Toyota production system, in a kind of like an Americanized version of it. How the Toyota production system should be brought to America. And it was written in the 80s. And it's all about work in progress and cleaning your environment and getting rid of stuff that gets in your way and just obscures everything so you can't see what's going on. Effectively, it was a precursor to Lean, which I think is really very well aligned. Green and Lean,
Absolutely.
really, really very well aligned.
Yeah.
And it's something that we don't think about, that cleaning up waste just makes your life much better in ways that are hard to imagine until you've done it. And cleaning zombie servers up just makes your systems more secure, cheaper, more resilient, more everything. It's a really good thing to do.
Yeah, and there's sort of another way that those align as well, which I think is interesting because I think it's not necessarily intuitive, which is sometimes when we talk about zombie servers and server waste, people's first response is, this is terrible. The way I'm going to solve it is I'm going to put in barriers in place so that getting a server is harder. And that seems really intuitive, right? Because it's like, oh, yes, we need to solve it. But of course, it has the exact opposite effect. And again, it seems so counterintuitive because it seems like if you have a choice between shutting the barn door before the horses left and shutting the barn door after the horses left, you should shut the barn door before the horses left. But what happens is that if those barriers are in place, once people have a server, if they had to sweat blood to get that server, they are never giving it up. It doesn't matter how many thriftathons you do, they are going to cling to that server because it was so painful to get. So what you need to do is you need to just create these really sort of low friction systems where it's easy come, easy go. So it's really easy to get the hardware you need. And so you're really willing to give it up. And that kind of self-service model, that kind of low friction, high automation model is really well aligned again with Lean. It's really well aligned with DevOps. It's really well aligned with cloud native. And so it has a whole bunch of benefits for us as users as well. Of if it's easier for me to get a server, that means I'm more likely to surrender it. But it also means I didn't have to suffer to get it, which is just a win for me personally.
It is, and there's something at the end of the goal, in the little bit at the end, which I thought was, oh my goodness, the most amazing. I'm getting a bit of a light switch moment for me when it was talking. This is still about 10 years ago, but it's talking about ideas about stuff that basically underpin the cloud, underpin modern computing, underpin factories and also warehouses. And because I'd worked for a long time in companies that had warehouses, so you kind of see that there are enormous analogies. And it was talking about how a lot of the good modern practice in this has been known since the 50s. And even in places like Japan, where it's really well known. I mean, Toyota the Toyota production system is so well known in Japan. Almost everybody knows it. And every company in Japan wants to be operating in that way. Still, the penetration of companies that actually achieve it is very low. It's only like 20%. And I thought, it's interesting. Why is that? And then I realized that he'd been kind of hinting why it was throughout. And if you look on the Toyota website, they're quite clear about it. They say the Toyota production system is all about trial and error. Doesn't matter. You can't read a book that tells you what we did and then say, oh, well, if I do that, then I will achieve the result. that would say it's all about a culture of trial and error. And then you build something which will be influenced by what we do and influenced by what other people do and influenced by a lot of these ideas. But fundamentally, it has to be unique to you, because anything complicated is context specific. Therefore, you are going to have to learn from it. But one of the key things for trial and error is not making it so hard to try something and so painful if you make an error that you never do any trial and error. And I think that's very aligned with what you were saying about if you make it too hard, then nobody does any trial and error.
Mm-hmm. Yeah, absolutely.
I wrote a new version of it called the Cloud Native Attitude, which was all about, what are people doing? What's the UK enterprise version of the TPS system?
Yeah.
And what are the fundamentals and what are people actually doing? And what I realized was that everybody was doing things that were quite different, that was specific to them, that used some of the same building blocks and were quite often in the cloud because that reduced their bottlenecks over getting hardware, because that's a common bottleneck for everybody. So they was to reduce the bottleneck there of getting the access to hardware. But what they were actually doing was built trial and error wise, depending on their own specific context, and every company is different and has a different context. So you have to be able to that is why failure is so can't be a 4-letter word.
Yeah. Technically, it's a 7-letter word if you say failure,
and it should be treated that way. I'm very aware that actually our brief for this was to talk about 3 articles on AI.
I have to say, I did have a bit of a panic when I was reviewing the articles, because they were very deep into the sort of the intricacies of, AI policy and AI governance, which is not my specialty area.
No, neither is it mine. All that, and when I was reading it, I thought quite a lot about what we've just talked about. It is a new area. It's something that as far as AI is concerned, I love AI. I have no problem with AI. I think it's fantastic. It's amazing what it can produce. And if you are not playing around on the free version of ChatGPT, then you are not keeping on top of things, because it changes all the time. And it's very like managing somebody.
Yes.
You get out of it what you put in. If you make a very cursory, ask it a couple of cursory questions, you'll get a couple of cursory answers. If you, leaning back on Toyota again, you almost need to 5 whys it. You need to kind of like, but why? Go a little bit deeper. Now go a little bit deeper. Now go a little bit deeper. And then you'll notice that the answers get better and better and better, like a person. Better and better and better. So if you really do, it is worth playing around with it.
Just on that, I was just reading an article from Simon Willison this morning, and he was talking about sort of, a similar idea that, you have to put a lot into it, and that to get good, he was talking about it for coding assistants, that, to get good outputs, it's not trivial. And a lot of people will sort of try it and then be disappointed by their first result and go, oh, well, it's terrible, and dismiss it. But he was saying that one of the mistakes that people make is to anthropomorphize it. And so when they see it making mistakes that a human would never make, they go, oh, well, this is terrible. And they don't think about it in terms of, well, this has some weaknesses and this has some strengths, and they are not the same weaknesses and strengths as a person would have. And so I can't just see this one thing that a human would never do and then dismiss it. You need to sort of adapt how you use it for its strengths and weaknesses, which I thought was really interesting. The sort of it's so tempting to anthropomorphize it because it is so human-ish in its output, because it's trained on human inputs, but it does not have the same strengths and weaknesses as a person.
Well, I would say the thing is, it can be used in lots of different ways. There are ways you can use it which actually it can react like a person, and therefore does be thought. But if you ask it to do creative things, it's quite human-like, and it will come up with, and it will blag, and it will it's you just have to treat it to a certain extent. On creative things, you have to go, is that true? Can you double check it? Is that, I appreciate your enthusiasm there, but it might not be right. Can you just double check that? In the same way that you would do with a very enthusiastic graduate. And you wouldn't fire them because they said something that seemed plausible. And well, unless you'd said, do not tell me anything that seems plausible, but you haven't double checked. Because to a certain extent, they're always enthusiastic. And that's where ideas come from. Stretching, saying, well, I don't know if this is happening, but this could happen. You have to be a little bit out there to generate new ideas and have new thoughts. I heard a very interesting podcast yesterday where one of the Reeds, I can never remember if it was Reed Hastings or Reed Hoffman, it's like we're talking about AI. It was AI energy use, and he was saying we're not stupid. If basically there are two things that we know are coming. One is AI, and one is climate change. We're not going to try and create an AI industry that requires the fossil fuel industry, because that would be crazy talk. We do all need to remember that climate change is coming, and it is a different model for how. And if you are building an AI system that relies on fossil fuels, then you are an idiot, because the big players are not. I love looking at our world in data and looking at what is growing in the world. And if you look to a chart that's really interesting to look at, if you ever feel depressed about climate change, is to look at the global growth in solar power, in solar generated power. It's going up it's not even exponential. It looks vertically asymptotic. It's super exponential. It's going faster than exponential. Nothing else is developing that way. Except maybe AI, but AI from a lower point, and actually I think the AI will. And then you've got things with AI. You've got stuff like DeepSeek that's coming out of left field and saying, "Do you just didn't need to write this so inefficiently. You could do this on a lot less, and it would be a lot cheaper, and you could do things on the edge that you didn't know that you could do." So I'm not too worried about AI. I think that DeepSeek surprised me.
Yeah, I agree. I think we have been seeing this, sort of enormous rise in energy consumption, but that's not sustainable. And it's not sustainable in terms of climate, but it's also not sustainable financially. And so financial corrections tend to come before the climate corrections. And so what we're seeing now is architectures that are designed to reduce the energy costs because they need to reduce the actual financial costs. So we get things like DeepSeek, where there's the sort of the fundamental efficiency in the model of the architecture, or the architecture of the model rather. But then we're also seeing things as well, like up until maybe a year ago, the way it worked was that the bigger the model, the better the results, just, absolutely. And now we're starting to see things where the model gets bigger and the results get worse. And you see this with RAG systems as well, where when you do your RAG experiment and you feed in just 2 pages of data, it works fantastically well. And then you go, okay, I'm going to proceed. And then you feed in 2,000 pages of data, and your RAG suddenly isn't really working, and it's not really giving you correct responses anymore. And so I think we're seeing an architectural shift away from the really big monolithic models to more orchestrated models, which is kind of bad in a way, right? Because it means we as engineers have to do more work. We can't just have one big monolith and say solve everything. But on the other hand, what do engineers love? We love engineering. So it means that there's opportunities for us. So, a pattern that we're seeing a lot now is that you have your sort of orchestrator model that takes the query in and triages it. And it says, is this something that should go out to the web? Because actually, that's the best place for this news topic, or is this something that should go to my RAG model? Is this something, and so it will choose the right model. Those models are smaller, and so they have a much more limited scope, but within that scope, they can give you much higher quality answers than the huge supermodel, and they cost much less to run. So you end up with a system, again, it's about the double win, where you have a system which maybe took a little bit more work to architect, but gives you better answers for a lower cost.
That is really interesting. And more aligned as well with how power is being developed potentially. That there is, you really want to be doing more stuff at the edge, which means that you want people to be doing stuff at home on their own devices, rather than just always having to go to, as you say, supermodels are bad. We all disapprove of supermodels.
Yeah, and in terms of, that aligns with some of the sort of the privacy concerns as well, which is, people want to be doing it at home, and certainly organizations want to be keeping their data in-house. And so then that means that they need the more organization local model to be keeping their dirty secrets in-house.
Well, it is true. I mean, the thing is, it is very hard to keep things secure, and sometimes you just do want to keep things in-house. Some of your data in-house. You don't necessarily even want to stick it on Amazon if you can avoid it. Mm-hmm. But yes, so that's been a really interesting discussion, and we have completely gone off topic, and we've hardly talked a little about the AI regulation. I think we both agree that AI regulation is quite soon to be doing it. It's interesting. I can see why the Americans have a tendency to take a completely different approach to the EU. If you look at their laws, and I did do some lecturing in AI ethics and legalities. And American laws do tend to be like, well, something goes wrong, get your pantsuit off and fix it. EU laws tend to be about don't do it. As you said, close the door before the horses, is bolted. And the American law is about bringing it back. But in some ways, that exemplifies why America grows much faster than Europe does.
Yeah, I was when I was looking at some of the announcements that did come out of the AI summit, I think, I have really mixed feelings about it, because I think I generally feel that regulation is good, but I also agree with you that it can have a stifling effect on growth. But one thing that I think is fairly clearly positive that did seem to be emphasized in the announcements as well is the open source aspect. So like we have, sort of open source models now, but they're not as open source as, open source software in terms of how reproducible they are, how accessible they are for people to see the innards of. But I think I was thinking a little bit again when I was sort of the way the AI summit is making these sort of bodies that have like the public-private partnerships, which isn't anything new, but we're sort of seeing quite a few governments coming together. So like the current AI announcement, I think, had 9 governments and dozens of companies. But it reminded me a little bit of the sort of the birth of radio, when we had this resource, which was the airwaves, the frequencies that nobody had cared about, and then now all of a sudden it was quite valuable, and there was potentially, this sort of wild west of like, okay, who can take this and exploit it commercially? And then governments stepped in and said, actually, no, this is a resource that belongs to all of us. And so it needs to be managed, who has access to it and who can just grab it. And I feel a bit like, even though in a technical sense, the data all around us isn't all of ours, it's, a lot of it is copyrighted and that kind of thing. But if you look at the sort of the aggregate of like all of the data that humanity has produced, that is a collective asset. And so it should be that how it gets used is for a collective benefit, and that regulation and making sure that it's not just one or two organizations that have the technical potential to leverage that data is a collectively good thing.
Especially at the moment, we don't want everything to be happening in the US, because maybe the US is not the friendly partner that we had always thought it would be. And
diversity is good. Diversity of geographic interests.
Indeed, yeah, it is. Yeah. So yeah, but it is early days. I'm not an anti-AI person by any stretch. In fact, I love AI. I think it really is an amazing thing, and we just need to align it with the interests of the rest of the humanity in terms of.
Yes.
Yeah, but it is interesting. They're saying that in terms of being green, the big players are not idiots. They know that things need to be aligned. But in terms of data, they certainly will be acting in their best interests. So yeah, I can see yeah, indeed, very interesting. So we are now coming to. We've done quite a lot Yeah, there won't be much to edit out from what we talked about today. I don't think it's very good. But
shall we talk about the Microsoft article though? Because I thought that was really interesting.
Oh yeah. Go for it. Yes, that's true.
Yeah. So one of the other articles that we have is it said that Microsoft was reducing its investment in data centers. Which I was quite shocked to read that because it's the exact opposite of all of the news articles that we normally see, including one I saw this morning that said that, the big three are looking at increasing their investment in nuclear. But I thought it was sort of interesting because I think we always tend to sort of extrapolate from the current state and extrapolate it indefinitely forward. So we say demand for AI is growing, demand for AI will grow indefinitely. But of course, that's not sustainable. Again, it's not sustainable in terms of financially. And so at some point there will be that correction. And it seems like Microsoft has perhaps looked at how much they've invested in data centers and said, oh, perhaps this was a little bit much. Perhaps let's roll back that investment just a little bit because now we have an overcapacity on data centers.
And I wonder how much of DeepSeek had an effect on that, which is that everybody was looking at it and going, thing is, Azure is not, well, I say this is a public story, so because I have it in the book, the story of during the pandemic, the Microsoft Teams folk looking at what they were doing and saying, could this be more efficient? And the answer was yes, because they had really no effort in whatsoever to make what they were doing efficient, really basic efficiency stuff they hadn't done. And so there was tons of waste in that system. And the thing is, when you gallop ahead to do things, you do end up with a lot of waste. DeepSeek was a great example of, this AI thing, we can do it on like much cheaper chips and much fewer machines. And you don't have to do it that way. So I'm hoping that this means that Microsoft have decided to start investing in efficiency. It's a shame because they used to have an amazing team who were fantastic at this kind of stuff. I was saying, Holly spoke at a conference I did last year about code efficiency and Quarkus being a really good example of a more efficient platform for running Java on. The first person I had on that used to work for Azure and was probably the world's expert in actual practical code efficiency. He got made redundant because Microsoft at the time were not interested in efficiency. So who cares? Gone out. But he's now working at NVIDIA doing all the efficiency stuff there because some people are not paying attention to. I think the lesson there is that maybe Microsoft were not paying that much attention to efficiency. The idea that actually you don't need 10 data centers, a little bit of easy, very difficult change to make it really efficient, but quite often there's a lot of low-hanging fruit in efficiency.
Yeah, absolutely. And you need to remember to do it as well, because I think probably it is a reasonable and correct flow to say innovate first, optimize second. So you don't have to be looking at that efficiency as you're innovating because that stifles the inefficiency, and you might be optimizing something that never becomes anything. But you have to then remember once you've got it out there to go back and say, oh, look at all of these low-hanging fruit. Look how much waste there is here. Let's sort it out now that we've proven it's a success.
Yeah, it is. Yes, it's like don't prematurely optimize does not mean never optimize.
Yes.
So my strong suspicion is that Microsoft are kind of waking up to that a little bit.
Yeah.
The thing is, if you have limitless money and you just throw a whole load of money at things, then it is hard to go and optimize. As you say, it's a bit like that whole thing of going in and turning off those zombie machines. You have to go and do it.
Yeah.
You have to choose to do it. If you have limitless money, you never do it because it's boring. It's not as exciting as a new thing. Yeah. But limitless money has its downsides as well as it.
Yes. Who knew?
Yeah. But so I think we are at the end of our time. Is there anything else you want to say before you? It's been an excellent hour.
No. It's been absolutely fantastic chatting to you, Anne.
Excellent. It's been very good talking to you as always. And so my final thing is, if anybody who's listening to this podcast has not read Building Green Software from O'Reilly, you absolutely should, because a lot of what we just talked about was covered in the book. reviewed.
I can recommend the book.
I think your name is somewhere as some nice thing you said about it somewhere on the book cover. But so thank you very much indeed. And just a reminder to everybody, everything we've talked about, all the links in the show notes at the bottom of the episode. And I will see you again soon on the Environment Variables podcast. Goodbye.
Hey everyone, thanks for listening. Just a reminder to follow Environment Variables on Apple Podcasts, Spotify, or wherever you get your podcasts. And please do leave a rating and review if you like what we're doing. It helps other people discover the show. And of course, we'd love to have more listeners. To find out more about the Green Software Foundation, please visit greensoftware.foundation. That's greensoftware.foundation in any browser. Thanks again, and see you in the next episode.